Hello there. In this video I'm going to be doing another teardown review of a FNIRSI product. This time it's the DMT-99 multimeter. And before you think, oh, not another review of a budget multimeter, well, this one stood out to me and seemed worthwhile doing because it's got a couple of interesting features. First of all, it's got a recording mode which gives a graphical representation of the multimeter readings. And another one is a monitor mode where it can give a visual and audible alarm when certain inputs are above or below a certain predefined threshold. And in addition, it's got a really low price. It's actually really good value. Now initially, I don't know what you'd think, I was put off by the styling. I kept out thinking they've gone a bit too far to make it look futuristic, and it's in danger of looking a bit like a toy. I think my first impressions was it looked a bit like a spaceship. Still, that's subjective. I don't know what you think. So I contacted FNIRSI and said, look, would you be interested in me reviewing the DMT-99 so long as I can give an unbiased and honest review? And they said, yep, they're fine with that. So they kindly sent me one. But apart from that, I just want to make it clear that apart from receiving this multimeter, which is a low value item, I don't receive any commission for the sales of these devices. I'm reviewing this purely because it looks interesting and I think it would be interesting to my audience. So thank you very much, FNIRSI, for sending me this device. Now, a word about firmware. So I'm conducting this review on the version of firmware that was shipped with the product, which is version 2.1. But you'll note from the release notes that I've shown here, the version has since increased to version 2.4. The reason I haven't updated the firmware prior to doing this review is just in case something goes wrong with the update process and I brick the device and then I can't do my review. But towards the end of this video, I will be updating to the latest version of firmware, and I'll show you how to do it, just as we should do in any good review. So hang around to the end and we'll make sure that you're up to date. So just know, any functional or software issues we might observe as we do this review may just be caused by version 2.1 and may be fixed in later versions. Now, to make this video easier for you to pop in and out, so you could use it more like a reference than a story, I put together a little contents list for you. So let's have a quick look. So first of all, we're going to do an overview and look at the main specifications. Then we're going to do a teardown of the hardware and do a hardware review. We'll do a bit of a chip reveal in there as well and look at the architecture. Then we're going to dive into the multimeter performance and look at the accuracy of the basic multimeter functions. And then we're going to look at this non-contact voltage feature and live function. And then we're going to look at these special modes, which is the recording and monitor modes. Then we're going to look at the process for upgrading the firmware. And then we're going to look at a undocumented function that I came across, which I think you'll find interesting. And finally, but not least, we'll do a review and look at the cons and pros of this device. And at this point, I'd just like to ask a little favor of you. It takes a lot of time and effort to produce these videos. And I notice around 99% of my viewers don't actually subscribe to the channel. It would mean so much to me and really help my channel if you could hit that subscribe button and would help me provide more videos like this in the future. Now, if you need to have some PCBs professionally and quickly prototyped, then check out the sponsor of today's video, PCBWay. PCB manufacturing options include flexible PCBs, HDI, and they also offer the service to do PCB assembly for you. In addition to PCB manufacturing, they also offer facilities for CNC machining and professional 3D printing. They also have a fantastic online community where other makers share their projects. So for more information, go to pcbway.com and I'll put in a link in the description. And as I've come to expect, FNIRSI products are always exceptionally well packaged. This one's no different. It amazes me. This device retails for around 26 British pounds or 32, 33 US dollars delivered. It amazes me how this company can produce it, package it and deliver it for this price and still make a profit. Well, I assume they're making a profit. So here's the basic parameters. As you can see, it's a 10,000 count multimeter. Accuracy is nothing to write home about. 2.4 inch TFT display. What else have we got? Capacitance, frequency, temperature, non-contact voltage detect, live wire detect. Oh yeah, that's well packaged. Nice manual. The FNIRSI manuals are generally quite good. They do come in multiple languages, and the English translation at least is quite good compared with competitor products. The manuals are not amazing, but they do tell you what you need to get going. There's parameters again. We'll look at those in a bit more detail later. I think the accuracy is very similar to the FNIRSI 2C23D combination oscilloscope, multimeter and function generator I reviewed previously. Okay, there's the manual. As usual, FNIRSI products are bagged for freshness. And the first thing to comment is very light, quite compact, but yeah, really light. But it's not flimsy. It feels quite solid. You see, it's got a handy little hook at the back, flip out stand. It's quite sturdy, it's not too bad. Here's the little hook. You can hang it on the wall if you're so inclined. Reset button at the bottom there. USB-C charging. Looks good. Very reflective display, but I don't think that's a particular problem. Standard issue multimeter probes. Wow, they are very sharp. That's good. $20 amps. I don't believe that. The cables are quite flexible. And of course the USB-C charging cable. It'd be good if FNIRSI used eco packaging such as cardboard instead of that plastic foam. Now let's do a size comparison. So you can see how small that FNIRSI multimeter is compared with the Fluke and Uni-T. And you wouldn't believe how much lighter it is. It feels like half the weight. You can see the size comparison there. The Uni-T is quite a chunky multimeter, I must say, but yeah, it looks tiny, and it doesn't have the rubber bumper around it like the Uni-T and the Fluke does. But then at that price point, what would you expect? Now let's have a look at the weight. I'm interested to see how much lighter it is. So here's a Fluke 79, and that weighs just over 400 grams. And then the Uni T61D, that's at 377. And then just for reference, the 2C23T 290, and the FNIRSI DMT-99 is 187. I told you it was light. Now, I also want to show you the probe clip on the back, which I think is quite handy. It's quite neat. Really appreciate that. Thank you very much, FNIRSI. Sishet. Now, let's get on with a teardown. So there we have it. Firstly, I can see the 1500 milliamp battery as advertised. Okay. Yeah, 5.55 watt hours. It's quite a simple construction, but looks adequate and as expected for the price. Okay, so what we got was a very neat and sparsely populated PCB. And first of all, I can see the split 4mm jacks, but they do seem tight and quite good to use. So we've got ceramic 5x20 fuses. They'll be rated at 250 volts or thereabout. We've got PTC, and so we've got some MELF resistors in series there, providing the input impedance. And then you can see we've got our multimeter IC that's connected to looks like a lot of dividing resistors and associated capacitors. We got the current shunt there for the 10 amp range, the reset switch, and there's a couple of transistors there wired in bipolar Zener mode, little switching relay. And here you can see the multimeter IC and associated 8 MHz crystal. Even though it's been lasered off, I happen to know that this is an SD7502, a 24-bit ADC multimeter IC. Now, I couldn't find the data sheet for the 7502, but I did find it for the SD7501, which I'm sure is in the same family and very similar. And as you can see from the description, it is a 24-bit multimeter IC. Notice that it's virtually a complete multimeter on a chip. It's even got a display driver. And if you look at this typical application note, you can see it does pretty much everything in a single package to provide you with a basic multimeter system. So then, moving across, we can see that we've got a connector there probably for programming or testing, and then you've got two LEDs there which shine through holes to the power button on the other side. So this gives an indication when it's charging or fully charged. That's pretty neat. And then it looks like the group of components here looks like we've got a voltage regulator and power systems and some switching transistors, probably for controlling LCD backlight brightness. And then we've got here a 64 megabit flash memory. And then we've got what have we got here? We've got our charge management IC, which is a TC4056A. And we've got the non-contact voltage detector, looks dubious. And at the heart of the system, we've got our microprocessor unit, which is a, just want to try to read that upside down. It'd help if I turned it up the right way, which is a CH32V303, which is a 32-bit RISC microprocessor. Now the variant we have is the RCT6, which if you look at the information here is the version with 256K flash and 64K SRAM, plus a few other features that the lower processor variants don't have. Okay, there's not much left on this board really. Looking at that multimeter IC and crystal and its arrangement, it looks like it's the same as on the FNIRSI 2C23T. Maybe we would check that out a bit later. And here is a high-level system diagram showing all of the key components which make up the DMT-99. Just in case you're interested. Okay, so let's look on the other side of the PCB. The quality of the construction actually looks pretty good. Again, I find it amazing how this sort of quality can be produced at the price that it's being sold at. It's quite incredible. Let's ease this out. Okay, have to be careful with that ribbon cable. Well, as expected, not much going on the underside. That ribbon cable with actually components actually mounted in the flexible part. And you see we've got that effective bridge rectifier with a diode across the middle of the rectifier to provide transient suppression, probably be for the current range. You can see the extra thick tracks for current, a few capacitors and pads for the push buttons. What else have we got? Now here you can see the holes with the LEDs shining through for the power button, and there's the pads for the buttons. And you can see the transparent section around the power button to allow the light pass through. The construction's as expected. It's not bad for the price. Now let's have a look at the multimeter IC again. And you look at the arrangement. So you've got the crystal near the pin 1 marker, and then the pin outs go into the array of capacitors and resistors on the pin 1 side. And the data connection on the opposite side. That's probably the RX and TX. That's your communication to the main microprocessor. And there we've got connections to the crystal, and looks like connections to a programming port. Now let's compare that with the FNIRSI 2C23T. And you see you've got a crystal device on the pin near the pin 1 marker. You've got an array of capacitors, resistors on the pin 1 side, and then it looks like you've got a data connection on the opposite side going via the opto-isolator. So yeah, I think it's the same device. Pretty sure it is. So I'd expect all of the accuracy and performance of the 2C23T to be similar, if not identical, to the DMT-99. So let's have a look at the current consumption. So I've got the multimeter on the right in series between the battery of the DMT-99 and its power supply. And you see we're drawing around 96 milliamps. We might be able to reduce this by reducing the screen brightness, but let's assume it's 100 milliamps for argument's sake. Now, with 1500 milliamp hour battery and 100 milliamp consumption, so that should give us around 15 hours. Let's just double check. Well, there you are, 15 hours. So you'll probably safely assume 10 or 12 hours continuous use with that maximum screen brightness. So that's not good compared with a traditional multimeter, but because you can charge it via USB-C, maybe that's not such of an issue. Now let's have a look at the navigation buttons. The top button is used to select between hold and relative. The button on the right cycles between voltage, ohms, continuity, and so on, capacitance. But notice the relative button is not, or function is not available on all ranges. You'll notice available on capacitance, but if I go to resistance, and it's a long press for relative, short press for hold. So if I try and get relative, it doesn't work. That's a pain because that's good for compensating probe resistance. That's a surprise. The bottom button cycles between frequency, temperature, live detect, and non-contact voltage detect. And then the button on the left cycles between milliamps and amps, both AC and DC. And then you can see you've got the bar graph going at the left and the right. I know some people don't like it, but I think it's actually quite good and handy to have to show you trends. I'm now going to show you the setup menu. So the first thing, you've got the mode selection. So regular is your standard multimeter mode, recording and monitor modes are these special modes which I will show you later. Then we've got threshold settings used in conjunction with monitor mode. So these are the thresholds that you can set for voltage, current and temperature when you get audio and visual alarm. And then we got history record. So this is where in record mode you can sample either under gear you've got voltage, temperature or current, I believe it is, or resistance, I can't remember now. Then you've got system settings. You can change the theme of the user interface. It's either here or there. It just changes text, colors, etc. Language, of course. Brightness, you might be able to save some current consumption there. Temperature settings, centigrade, Fahrenheit, and of course shutdown. I recommend you put the shutdown on here because it's easy to hit the power button because it's raised up. So it's easy to inadvertently hit that button when it's in your bag and you're going to lose all your battery. And then of course we've got reset and about information. Okay, let's talk about the multimeter specifications and accuracy tests. So I noted that looking at the specifications for the DMT-99, they are exactly the same as the FNIRSI 2C23T, which is the multi-function oscilloscope signal generator and multimeter that I did a teardown and functional review on a few months back. So that's not surprising because as we saw from the teardown that we just did in the hardware review, you'll note that the multimeter chip and multimeter front end appear to be exactly the same as the FNIRSI 2C23T. Now, I went through all the tests and I note that all the tests passed successfully, showing that the multimeter is performing within its specification. Now, there's around 25 minutes of footage showing you all this, and as I've already effectively done it for the FNIRSI 2C23T, I thought, well, what's the point? If you're interested in how I did the test and what the detailed results were, then I'd encourage you to look at the functional test I did on the FNIRSI 2C23T, and I'll drop the link to that video in the description. So with that said, let's fast forward through the accuracy checks and move on to the juicy and interesting things that make this multimeter unique. So now what I'm going to do, I'm going to use the multimeter on the left to check the continuity between the common connection on the DMT-99 and its USB port. So you can see that the common on the USB port is connected to common on the multimeter. So this is a concern, right? If you're measuring live voltages and you've forgotten to take the USB cable out, those live voltages could be appearing at the end of your USB cable. So the way they've got around this is that if you plug the USB port into a charger, it basically disables multimeter functions. Of course, it doesn't help with the isolation, but it's a good reminder. But note that if you're not applying power to that USB port, then it won't give you a warning. And you can see here the light behind the button showing you that it's charging, which is pretty cool. So be warned and please use it with caution. Now let's have a look at the non-contact voltage function, or NCV. One thing to note is it doesn't actually tell you, it just puts up a display. It'd be nice if it had a title. So the idea is that if you bring a live conductor near that NCV sensor at the top, it tells you with this audible and visual indicator, but it's not sensitive at all. You see, it's not actually doing anything unless you put the sensor really close to the cable. So in my mind, that's really not useful. In fact, I would discourage using it because you might get a false indication. You might think a cable's not live, but it's simply because you're not close enough to it, and then you put yourself in a potentially dangerous situation, risky situation, because you're not getting indication it's live. Now, the other function is the live function. The idea here is you just use a single probe to determine if a conductor is live or not. So this earth is not showing anything, neutron not showing anything, and live. There you have it. So this one is more useful, I guess. But the NCV function, I think it's completely pointless, to be honest. Right, the next thing I'm going to do is have a look at the monitor mode. So the first thing you do is go into settings and set one of the three sets of thresholds, either voltage, current, or temperature. In this example, I'm going to use voltage. I set the minimum to 1 volt and the maximum to 3 volts. Now, as long as the input voltage remains within 1 and 3, I won't get an audible or visual alarm. The next thing to do is go into mode setting and make sure we're selected monitor. Okay, so on the left you can see that I've got a DSO-TC3 function generator, and I've set the output voltage to 1.9 volts DC. So you can see that's within my range. Now I'm going to increase it to 3 volts and we should get an audible and visual alarm. There you are. So at 3.1 I get the alarm. You can see the display on the FNIRSI DMT-99 showing max. Now I'm going to go the other way, so let's take it down to less than 1 volt. And there you go. It's a pretty useful feature. You could even use it as like a temperature alarm, battery over voltage alarm, battery under voltage alarm, so many things. I think it's a really useful feature. Great job, FNIRSI. I'm now going to look at another unique and interesting feature about this multimeter, which is the record mode. Now I've already been into settings and selected record mode. Connected to my precision attenuator to the potentiometer outputs, So I'm just twiddling the knob here to change the resistance. As you can see, it's being graphically represented. How cool is that? Another clever thing is it scales the y-axis according to the maximum minimum data values caught within the last 30 or so seconds. Now, something else I want to show you is every time I press the auto menu button, it records the value in that list on the right hand side. If you can see there, I've pressed it twice so far, so I've got 2 resistance settings in there. Now, just hold on to that thought for a moment because we'll come back to that. I'm going to now change to capacitance, and then I'm going to take a reading of capacitance. It happens to be 0, but never mind. Another reading from voltage, and then I'm going to go to temperature. Let's record another reading. There you go. So I've got some voltage, capacitance, resistance, and temperature. Now let's go to the menu, and there you can see that in history record I've got all of those snapshots or recordings of values that I've taken, their type and their value. Not sure how useful that is, but definitely the graphical representation of multimeter readings is great, I think. Now let's have a look at how we use thermocouples for temperature readings. Now a lot of thermocouples like this one come with two 4mm jacks with a standard 19mm spacing. So as you can see here, we can plug it straight into a multimeter with standard space inputs. But unfortunately, the DMT-99, the inputs are just too close together. Same problem with the 2C23T. But FNIRSI, please, in your future models, put your inputs as standard 19mm apart. But no big issue because we can use an alternative thermocouple like this one here, which has loose 4mm plugs. Now, I've been comparing my DMT and Unity multimeters and their performance with thermocouples, and they're pretty much on par, so no problem there. Now, it would appear that there's a temperature reading being given even when no thermocouple's plugged in, so I want to know if it's the internal thermocouple that's being used. So let's stick it in the freezer for a while and find out. So after 15 minutes or so, it has gone down. And there's my cat asking for fish fingers. So yes, when you haven't got an external thermocouple plugged in, it seems to use an internal temperature sensor, just like FNIRSI 2C23T does. So now that I've completed my testing, I'm going to upgrade the firmware to the latest version. So it was shipped with version 2.1, and I'm going to upgrade it to the latest, which you can see from these release notes is currently 2.4 as of March 2024. These release notes get packaged up and sent with the firmware itself, and it's in Chinese, but I've translated it here for you for your reference. I note that the release notes aren't particularly good, especially the last ones. It just says 2.3 fix some known issues, 2.4 fix some known issues. FNIRSI, it'd be great if you just tell us what issues you fixed, please. Right, without further ado, let's look at how we update the firmware. Now this might change by the time you have a look, but I found that I had to go to the Chinese language version to be able to find the firmware. In some cases the English site or English version of the site didn't have the firmware. So have a look carefully at how my screen's set up and what I've selected. So you can see I've gone to FNIRSI.com, download multimeter. I've got the Chinese language set, multimeter, and then this icon is for firmware. And here we can see it says PDF, but it's not PDF, it's actually the bin file, which is the executable. So I've downloaded it, So the downloaded file is a zip archive, so we need to extract it, and I'm extracting it here using Windows native zip extractor. Okay, and then you can see it creates a new folder, and in that folder you'll find another folder, and within that you'll find two files: the .text file, which is the release notes in Chinese, which I showed you earlier, and the .bin file. Now that's the downloadable file containing the executable firmware. So when we plug in the DMT in its boot mode or software download mode, we will copy that .bin file into the DMT's file system. Right, so the next step is to put the DMT into its software download mode. So you hold down the auto menu button while switching it on, and you see it's gone into the software download mode. Plug in a USB cable that's got a data connection, not just power, into your laptop. Copy that bin file. Then go to the drive which appears when you plug in the FNIRSI DMT, and then copy or paste that file into that drive at the lowest level, not any subfolders that appear within the drive. There we go. Then follow the instructions back on the DMT. You press the auto button once you copied the file, and it says be updating. Lovely. Okay, done. And then let's go in and check the version. So we go into settings, go down to about, and there we are, version 2.4. Bob's your uncle. Done. Now, I don't recommend you try this at home because you might completely screw up your meter, but if you hold down the top and bottom buttons and press power on, it goes into calibration mode. And you just wait, it does something interesting. It counts up. Like I say, don't try this at home unless you want to take the risk of buggering up your DMT. I presume this is a factory function that's intended to set up or calibrate the meter after it's finished its production process and before it gets shipped. But something interesting happens at the end. You just watch. Almost done. Okay, look, it presents a millivolt scale. We don't have millivolts normally in the standard multimeter voltage function. So that's interesting. So what I want to do is see if we can actually use this as a millivolt range. So I connected it to my precision attenuator, so I've got 10 volts going in, and it's attenuated to the point where we should have 100 millivolts coming out, and you can see on the fluke we indeed are getting 100 millivolts. So let's see what happens when we plug it into the FNIRSI in this mode. Oh, that's unexpected. It shows 193 millivolts. Okay, I think we're gonna abort this before I really screw up my DMT. That's a shame. I thought we could use it as a millivolt range. So I'm just going to play around with the other buttons whilst it's in that mode. Okay, the hold rail button doesn't do anything. Milliamp, amp. Oh, okay, it's gone into a kind of a resistance range. Maybe that's to calibrate resistance. Oh, and also temperature. I don't know why it's saying 90.5. And milliamps. It's interesting. Yeah, so I guess this is some sort of function they use in the factory to calibrate those different ranges. Oh no, what does that mean? See, I told you not to try this. Oh no. Does it come back on as normal? Oh, it hasn't done that before. Only when I started it for the first time. Have I buggered up the calibration? I'm gonna do a quick check. Alright, so here I am with my precision attenuator again. So 100 millivolts, and yay, I'm reading 100 millivolts on my DC input range. Thank goodness for that. Let's change it to 1 volt. Brilliant. It looks like it's okay. I've got to live another day. Okay, so I'm going to conclude this review now. First of all, let's have a look at the cons. So first of all, I note that the inputs are not cat rated. This is interesting because the FNIRSI 2C23T, which effectively has the same input stages, is cat 4 rated, believe it or not, whereas this one has no cat ratings whatsoever. But you know what? I've got to say, I think FNIRSI are being honest. I think you could take the view that they're being honest. And let's face it, really, they needed some balls to launch this product and not put any cat ratings against it when probably all their competitors are. But we can see it does have some input protection. It has, of course, fuses, replaceable fuses, which are ceramic type, and it also has a PTC. So it looks like it's designed to be able to be used with standard domestic mains voltages, but it'd be perfectly good enough for the average electronics hobbyist or maker, which I'm sure this is aimed at. The next point is the use of non-standard input spacings. The standard input spacing is 90 millimeters, which means you can't use it for some standard input jacks, such as those found on thermocouples, but not a great big thing. The NCV, or non-contact voltage function, is pretty useless and pointless. In fact, I would discourage using it because you might get a false indication of if something is live or not. The other one is no isolation between USB port and multimeter inputs. Not a surprise for a multimeter at this price point, but please do be aware if you've got your USB-C hanging out of this thing because you forgot to disconnect it, and then you're probing around in some high voltage mains equipment, you could end up with a nasty shock. So please be aware. And the relative function does not work for resistance. Hopefully that's fixable in software. I hope that's just an oversight, because this is a useful feature when you're trying to compensate for the resistance in your multimeter leads. Now let's have a look at the pros. So first of all, I keep saying this, but I think it's incredible value for money. Quite honestly, how they get that functionality, the quality of build and packaging and delivery for the prices that they do, which is about £26 UK, or around $32, $33 US at the time that I made this video. I just find that incredible. I don't know how they make a profit. Also, I just want to point out, although not directly related to this device itself, is the excellent customer service. You might note in the last video I made, I accidentally smashed the screen on my 2C23T. They've already sent me a replacement screen, and they've always responded to my technical inquiries really quickly and efficiently. Now that's important, I think, for any product. Also, I think that the interface is very easy to use, and unlike a traditional multimeter where you've got a rotary dial, you can operate this with one hand, a bit like you can with a mobile phone. So that's pretty good. And I think the record and monitor modes are not just gimmicks, they are actually useful. And this is why I wanted to review this multimeter in the first place. I think they really are going to be useful things to have.
And of course, you've got the rechargeable internal battery, which is unusual at this price point, and a great display. So would I recommend this? Well, I'd recommend it for hobbyists or people working on their car. I think it's good for auto and boat applications. I wouldn't recommend it for professional use, of course. It doesn't have CAT ratings. I wouldn't use it for high energy or mains work, except for occasional mains work, perhaps if you're diagnosing some domestic electronic equipment. But other than that, it's got a thumbs up. I'd recommend it. I actually quite like using it. So again, thank you, FNIRSI, for sending this across. And to all of you, if you found this video useful in any way or entertaining, please subscribe. It really does help my channel and help me to make more videos like this. Thank you so much. Take care and look after yourselves. Until next time.